All right, today we're going to look at the effects of an outlier. So what is an outlier? It is a data value that is numerically distant from the rest of the data set. So we're going to look at outliers and we're going to analyze the numbers and we're going to look at it and we're going to calculate the outlier based off of the formula. So when I think about an outlier, I think about something that doesn't necessarily fit in with the rest of the information that is given. So let's look at a few examples here. And if I'm looking at my first number line, I see that most of my numbers are falling between 1 and 5. And then I have this one value, 9.5, that falls outside of that range. That outlier doesn't fit in with the rest. So then I have this next set of numbers. They're ranging somewhere in the 20s. And then I have 9,000. So 9,000 definitely doesn't fit in with the rest of those numbers. It is falling outside of the typical data set. It is above that data set as well. That's going to make a difference when we talk about shape later on. All right, and then we have another set over here. Those are falling kind of between that 51 and 81 range. But we have 3, and 3 is going to be an outlier that's on the lower end. So how do we find the outlier, and how do we know for sure which ones are outliers? So any number that falls below Q1 minus 1.5 is an outlier. Any number that falls above the Q3 plus 1.5 is an outlier. So we have this data set here, and we're going to look at it, and we are going to calculate the actual 5-number summary. So we're going to look at this in Desmos and just going to talk through a few key points of doing that. So the first thing I'm going to do is I'm going to label my data. So I normally label with L just for list. You can label it anything you want to. Equals, and we have to use those square brackets. So I'm going to type in that information, being very careful as I type it in, and I want to make sure I go back and check those because you could easily mistype the wrong number and that's going to completely throw off your 5-number summary. Now I have 11 numbers, and I have 11 numbers that I've just put into my data set. So to find my 5-number summary, I'm going to go to Function, I'm going to go to Stat, and under Stats there's a Stats option, and we're going to tell it to find the stats for list L. And that is going to give me that 5-number summary. It's going to give me that it's going to give me that minimum, the Q1, the median, Q3, and maximum. So what we're going to do is we're going to calculate our 5-number summary based off of my Q1. So my Q1 is 79, and if we subtract 1.5, that is going to give me 77.5. So anything that is below 77.5 is an outlier. And then Q3 is 90 plus 1.5. So anything that falls above 92.5 is an outlier. So if I look at my numbers, I'm looking for numbers that are below 77.5, which I found is 55. And is there anything above 92.5? And I do not see that. So we have an outlier. My outlier is 55, and it falls below the Q1 minus 1.5. Okay, that's the reason why. So now what we're going to do is we are going to calculate the mean, median, mode, and range, and we're going to see how that outlier is going to affect that information with the outlier and without it, so that we can see that pattern that's happening. So we already kind of know a couple of things. We know the median with the outlier because we already had that 55 in the problem. So we know the median is 82. So my mode, remember mode is which one occurs the most. So as I'm looking here, so it looks like 91 is the one that occurs the most. And my range, so my range is my maximum minus my minimum. So my maximum was 91 and my minimum was 55. So that's going to be 36. So the only thing left we have to find is the mean. Well, we can easily find that in Desmos again. Now, I already know I can use the same list because that list is in there that we already have with the outlier. So I'm going to go to Stats, and I'm going to click Mean of list L. And it tells me that my mean is 81.5. So now what we want to do is we want to calculate this same information without 55. We want to take 55 out and see what happens. So when I take it out, I can easily just go to my list in Desmos. And that's the great thing about Desmos is you can adjust any list and it'll adjust your values as you take them away. So I now have 10 numbers because I took 55 out. And I'm now going to look. So my median is 82 without the outlier. My mean is 84.2 without the outlier. My mode, even though I took 55 out, is still going to be 91. And my range, so my range is going to be my maximum minus my minimum. So my maximum is 91 and my minimum is 78. So that's going to be 13. So what did it have any effect and what type of effect did it have? So if I didn't have the outlier, my mean was 84.2. So it did affect it. But how did it affect it? Well, when we put the outlier into the problem, it decreased my mean. Well, why did it decrease my mean? Well, it decreased my mean because 55 is on the lower end. If I had an outlier that was on the upper end, it still would affect it, but it would have increased the mean because it would have pulled it closer towards that outlier. Now, median. Well, median is the middle. The median can be affected by the outlier depending on how many outliers you have. But normally when we talk about the middle, remember the middle is just the number that's in the middle based off how many you have, is not normally affected by an outlier. Mode. Mode means the most. What number occurs the most? Well, if you have a number that occurs the most, then it's not going to be an outlier. Remember, outliers is what doesn't fit in. So if it doesn't fit in, it's not going to be in that most range. So the mode is not going to be affected. And the range. So the range is going to be the maximum minus the minimum. Well, without the outlier, our minimum, okay, because it's on the lower end, was only 78. Well, when we put the outlier in, the minimum is now 55. So it did affect it. It caused the range to increase. Well, why did it cause it to increase? Because you put in a number on the lower end that now increased the spread of my numbers from maximum to minimum. So just keep that in mind based off of whether it's on the lower end or the upper end, depends on how the mean and the range are going to be affected. Most of the time the median and the mode are not. Like I said, the mode can be affected slightly. That you would have to calculate it to be for sure. So now the question is, how does an outlier affect the shape? So when I look at this particular graph down here, so we normally think about shape. We have symmetric, we have skewed left, and we have skewed right. So in this particular situation, I have that bell shape. So this is very much a symmetric example here. So what happens if I have an outlier that is smaller? It's on the lower end. So if I have an outlier that is on the lower end, that is going to cause my information. So let's put it over here on the lower end. That is going to cause my graph to now be skewed to the left. Wherever you have an outlier is how the data is going to be skewed. So I now have a tail over here and it's going to be skewed to the left. Okay. So what happens if I have an outlier on the upper end? So let me go erase the one on the lower. So if I have an outlier that is on the upper end, so I'm going to put that over here on the upper end. So now I have a tail on the left side and it's going to be skewed to the right. So again, wherever you have an outlier is how your data is going to be skewed. Okay, think about the way that I think about it. I think about outliers skew the data. So wherever the outlier is going to skew it in that direction. So if I have an outlier that's on the lower end, that's on the left, so that's going to be skewed left. If I have an outlier that's on the right, then that's going to be on the upper end, so it's skewed right. So I hope this helps you understand the effects of an outlier. Just remember that outliers are always going to affect your mean and your range the most. Those are going to be the most affected, and how they're affected is based off of whether it's on the upper end or the lower end.